Good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. This week is all about taking a deep dive into climate change. We've been talking to scientists, to explorers, filmmakers who are researching, documenting, and of course, looking for solutions to our climate change issues across the globe. We've been looking at the Antarctic to the Arctic, diving into our oceans, exploring changes on land. It has been an incredible week so far. We're at the midway point with it being Wednesday, but we still have about, I'd say, 10 to 12 more events to go before the end of the week. So if you head to exploringbytheseat.com, you can find our climate series, sign up to tune in live on YouTube, sign up to snag a camera spot, and join in some of these amazing events. Well, I'm really excited for today's live event. Starting off our Wednesday, we have John Turner joining us. John has been a meteorologist for over 40 years. He's been with the British Antarctic Survey since the 1980s. While with the British Antarctic Survey, he's carried out research in Antarctica, looking at things like precipitation, polar lows, weather forecasting in the Antarctic. He's had a long involvement with the Scientific Committee on Arctic Research and is currently a member of the Antarctic Climate 2100 Steering Committee, and he's been awarded the International Journal of Climatology Prize of the Royal Meteorological Society, as well as a SCAR Medal of Excellence in Antarctic Research. So John is the guy to talk about Antarctica. So let me bring him in live here. Hey, John, how you doing today?
I'm great. How are you?
Good, good. It's great to have you joining us from Cambridge, live in the UK today. You were saying it's a nice looking day.
It's a beautiful day, a bit cool, but spring here, spring's on the way, and it'll be getting warmer soon, I think.
All right, excellent. Well, I want to give a shout out to the classes starting to join on YouTube. Let us know where you're joining from. Send us in some questions when the time comes, and we will work those in for John. But for now, John, I'm going to let you take over for a little bit. Take us into your world.
Great. Well, thanks, Joe. Well, I'm going to give you a flavor of why Antarctica is important and the sort of work we do down on the coldest continent on Earth, and particularly focus on climate change over the last few decades and what might happen over the next century. So just really a little bit about myself. When I was young, I was always really interested in the environment and making observations of weather, recording temperatures and barometric pressure. And basically, I'm still doing the same today. It's crazy after all these years, but it's a very exciting time for meteorology at the moment. And so I always wanted to do a degree in meteorology. I went to the University of Reading in 1974, and I did a PhD later. And I joined the Weather Service. It's the National Meteorological Agency, the Meteorological Office, and it's the obvious place to work if you're a meteorologist. And there I was involved in how satellites could help us understand the weather. I did some real weather forecasting, writing shipping forecasts, things like that. But in 1986, I got the chance to work at the British Antarctic Survey in Cambridge, just for 3 years initially, but it was just so much fun I never left, and I'm still here all these years later. And I mainly work in Cambridge, but I've been to the Antarctic 8 times over the years, and it's an amazing place to visit. I hope you all get a chance one day to go there. And I've often worked at our station called Rothera, which is on the Antarctic Peninsula, south of South America. This is a picture of the base from space. We have a crushed rock runway. You can see that long linear feature there. And we often fly in from South America, the Falkland Islands perhaps, on larger aircraft. And I worked on the base. I established a satellite receiving station there in the 1980s, so we could look at the weather systems. And then we use these small twin otter aircraft with skis and wheels. We take off with the wheels, and then we can fly into the deep field, into the middle of nowhere, land anywhere, put the skis down, and do work, such as drilling ice cores to look at past climate. And I'll give you an example of some of the work we do there. This is obviously a picture during the summer, because the base is completely surrounded by sea ice in the winter, frozen ocean, maybe only a meter or two thick, but it really locks in the Antarctic. But by this time of the year, you can see the floating icebergs. So this is clearly a summertime. So the arrow shows where Rothera is. It's south of South America there, and it's the warmest part of the peninsula. Temperatures get up above freezing in Rothera, maybe a couple of degrees in summer, We've actually had a temperature of 18 degrees at the tip of the Antarctic Peninsula. That's the warmest place in the whole of the Antarctic. Most of the Antarctic is very, very cold. And it is very isolated, whereas the Arctic consists of an ocean surrounded by the main continents. The Antarctic is completely different, like chalk and cheese. We have this huge block of ice there, surrounded by the Southern Ocean. The winds go round. We have the strongest winds on Earth around the continent. So it's very isolated, it gets very cold. And the temperature did get down to minus 89.2, high on the plateau of East Antarctica. But people often say to me, why do we care about the Antarctic? It's a long way from the main centers of population. It can't affect us. But that's not the case, because Antarctica contains 90% of the world's ice, which is 30 million cubic kilometers of ice. I always think that 1 cubic kilometer of ice is enormous, but 30 million is just mind-boggling. And this has all come from snowfall. It falls there and just doesn't melt, and so builds up and up. And if all the ice of the Antarctic melted, then sea level would rise by 60 meters. Now, that's not even going to happen on the scale of millennia, thousands of years. But if 1 or 2 meters of sea level happened because of melting in the Antarctic, that'd be really devastating for coastal communities, island nations. So we'd really like all that ice to stay in the Antarctic. And that's one of the reasons we monitor it so carefully. The rest of the world's ice is in Greenland, 9%, and just 1%, less than 1% in glaciers around the world. You hear a lot about glaciers melting and retreating, and that's certainly the case. But Antarctica is the big one, literally. That's what we really have to be worried about. Greenland's melting quite rapidly at the moment. And if you fly over it, you see melt ponds on the top of Greenland. And so that's a little bit of a worry as well. So we monitor Antarctica very closely. People first saw Antarctica from ships about 200 years ago. We just had the celebration of 200 years of people visiting the Antarctic. And in the early days, people established camps for maybe a month or 2 or a year, maybe 2 years. But if you're interested in climate and climate change, you want continuity. You need data day after day, year after year. And really the records we have for Antarctica from observers start in the late 1950s. The late 1950s was a time of real great tension with the Cold War happening. But the international scientific community really got together to coordinate the establishment of bases across the Antarctic. And the map on the right shows many of the stations which were established in the International Geophysical Year of 1957. Dumont d'Urville, France, Casey from Australia, Mirny was a Russian base. And so many of these stations have existed for 60, 70 years, and we have really good records. Of course, if you have a station, it's much easier to have it on the coast of Antarctica, where you can resupply it by ship. It's much more difficult having stations in the interior. But we have the US Amundsen Scott Station at South Pole and the Russian Vostok Station on the high plateau of East Antarctica, which have existed. So we have relatively limited records from the interior part of the continent. But we've made measurements, meteorological measurements, as we see here, by observers, surface, and we've sent weather balloons up, which give us some idea of what's happening at upper levels of the atmosphere. So, of course, you all know that the temperature of the world is increasing. This is the average temperature of the Earth. It varies year to year, decade to decade, because there's a lot of natural variability. And human beings didn't really start to affect the climate system till about the 1850s or so, when we had the Industrial Revolution, burning a lot of fossil fuels. Carbon dioxide started to increase then. But the temperature of the world held pretty steady until about the 1920s. And then we started to see this warming take place to about 1940. And then there was about 40 years when temperatures didn't rise. That just shows that the complexity of the climate system. But then from 1980 onwards, we really had this rapid warming, with temperatures overall increasing by about 1 degree over the last century. And so a big question for us all is what's going to happen in the future. So the world has been warming, but if you look at data from the Antarctic, you see this. These are surface temperatures, the graph, from 8 stations around the coast of East Antarctica. And these don't show a warming. And so that's exactly the sort of question that scientists like me are really interested in. And I always say, if you're interested in global warming, you have to look globally. You have to look at the average temperature of the Earth. You can't just cherry pick one little place and say, well, that shows global warming or doesn't. Global warming is global. So this is a really interesting question for scientists as to why the temperature of the continent hasn't changed since the 1960s. And the main factor is the ozone hole. The ozone hole gets a lot of publicity. We're always reading about it. But that raises a lot of questions. Why do we have an Antarctic ozone hole, but not an Arctic ozone hole? And why don't we have ozone holes in the tropics? And the reason is because Antarctica is so cold. We've been measuring ozone at our base, Halley, since the 1950s, because ozone is really important. There's a layer about 20 to 25 kilometers above the surface of ozone, which protects the Earth from ultraviolet radiation. Because ultraviolet radiation is really not good for the skin. Too much, you can get skin cancer, so you really need to put skin sun blocker on, especially in the Antarctic when we have the ozone hole. And so we have this relatively warm layer, and then suddenly the ozone started disappearing in the late 70s, early 1980s. And so there was a huge research initiative around the world to understand why this was happening. And it was traced back to gases called CFCs, chlorofluorocarbons, which used to be used in spray cans and in air conditioning systems. And people just never imagined this could cause any damage. These were thought to be totally inert gases, no harm to anybody, no problem. But they found that there was a very complicated chemical reaction that occurs every spring in the Antarctic because ozone builds up during the winter. And then when the sunlight returns in the spring, there was this reaction on polar stratospheric clouds. Clouds you only get at very low temperatures, very high up between CFCs, ozone, and these clouds. And that destroys the ozone above the Antarctic each spring. And so with the ozone gone, this warm layer has gone. And so the Antarctic has cooled a little bit. And so really that's negated the effect of greenhouse gases there, because carbon dioxide gas is well mixed across the Earth. It's increased above Antarctica like everywhere else on Earth, and it's now 400 parts per million. And so we get a little bit of warming from that, but the cooling from the ozone hole has knocked that out. And so we've seen very little change in temperature across the Antarctic. And so this is showing our base at the bottom at Halley Bay. We've been there since '57. This is the latest incarnation of our base. It's on floating ice, and so they last maybe 10 or 20 years, then they have to be replaced. But we have this amazing base there at the moment. And the graph shows the temperatures at Halley, which were starting to warm really up to about 1980, but then dropped rapidly and are slowly recovering a bit now. But overall, there's been no change. And people often say, now we've stopped emitting CFCs and spray cans and the like, is the ozone hole going to heal? Well, CFC lives a long, long time in the atmosphere. And so we reckon it'll be about maybe 2060, 2070 before we get rid of the ozone hole, get back to pre-ozone hole levels of temperature. So we're not getting much melt at the surface of the Antarctic because temperatures aren't changing a lot. But the danger to the Antarctic is the melt from below. That's where we're really seeing problems at the moment. And you see a lot of TV reports about parts of the edge of the Antarctic, like the Thwaites Glacier or the Pine Island Glacier disintegrating. And that's what's happening. The picture at the bottom shows the ice at the edge of the Antarctic continent, because I mentioned how cold the Antarctic is. It snows there, not a lot because it's a desert formerly. But when it snows, the snow builds up and up and up and up and doesn't melt. But it can't build up forever. And so it starts to flow in rivers of ice called ice streams down to the edge of the continent, where they break away as huge pieces of tabular icebergs. And so the schematic at the top shows one of these ice shelves at the edge of the Antarctic and warm water getting underneath because the world's oceans are warming. They're getting more acidic, which is not good either, and they're warming, and they're attacking the Antarctic from below. So this buttressing, this support of the Antarctic ice at the edge of the continent is disappearing to a certain extent. And we can monitor the state of the Antarctic ice from space. It's a huge, huge place, the Antarctic. It's 1.5 times the size of the US. So you can't monitor a lot of it when you're on the ice. And so we use space technology a lot. And satellites have instruments called altimeters, which measure their height above the surface very, very accurately to within centimeters. And that allows us to monitor the changes in the surface elevation of the Antarctic. And this figure is a composite of our current understanding of where ice is growing or shrinking. And the blues are slight increases of elevation of the order of very small amounts because of more snowfall. But there are large parts shown in red where the ice is disappearing. And this is disappearing up to 3-4 meters per year, the thickness of the ice is going. And so the ice is retreated in places like West Antarctica here on the left-hand side. Because Antarctica, the eastern part, this part here on the right, rests on rock, on mountains. There are mountains underneath the Antarctic, so it's very, very stable. Even if we're getting a little bit of melt at the edges, that's quite difficult to affect. But the West Antarctic ice sheet here on the left-hand side actually rests on the ocean floor. And that's very dangerous. It's a marine ice sheet. And so these warm waters are getting underneath. And so areas like the Pine Island Glacier, which I can indicate here, are disappearing and contributing to sea level rise. Because as I'm sure you know, sea level is rising. We've had tide gauges like the instrument shown at the bottom here on the coast around the world since 1880. All over the world, we measure the height of the ocean. And the ocean goes up and down because of tides, because of swell and waves and so on. But you can remove all that and get the average height of the ocean. And this shows the change at the top. Sea level has risen by about 20 centimeters since 1880. Now, it doesn't really sound a lot, but it's ongoing. It's not accelerating a lot yet, but the danger is the future. So sea level's rising at about 3.3 millimeters per year, 3.3 centimeters a decade. Antarctica is contributing about 0.5 millimeter a year. Most is coming from Greenland, about 0.7, about 0.6 millimeters a year from glaciers. The largest contribution is actually expansion of the ocean. Most objects, when you warm them, they get larger. And as the oceans warm up, they expand. And so about 1.8 millimeters per year of sea level increase is coming from expansion of the ocean. So the last thing I want to talk about briefly is the climate record locked into Antarctica. Antarctica is this huge block of ice, 3 kilometers high, part of 4 kilometers high, and we can drill down through it and collect cores of ice. And that they contain gases which allow us to understand and compute the temperatures existed in the past. Because the ice at the bottom of the Antarctic, some of it is over 1 million years old. We actually have a project at the moment to find the oldest ice on Earth. And that may be 1.3, 1.4 million years old. That'd be the oldest datable ice on Earth, and potentially could give us a fantastic climate record going back that far. But what we've done so far is we've drilled cores like this, 5 or 6 inches across, and you can see the little white dots in it. That is air trapped in the ice when the snow fell, because snow, when it falls, is very fluffy generally. But as the snow builds up and up and up, it reaches a point where it traps the air inside the ice, and then it's totally sealed in. And in laboratory conditions, as I was showing here, you can extract that air and measure things such as carbon dioxide concentration or methane. And you can also use different isotopes of oxygen to compute the temperature when the snow fell. This is really my last slide. We had an amazing project at a place called Dome C, shown here at the bottom left, which is high up on the plateau, very high elevation in East Antarctica. And they drilled through ice over 2 years, big project. And the ice at the bottom was 800,000 years old. That's the oldest ice we've got, which can be datable. And it's a bit like tree rings, where year by year, you can detect layers, usually using signals such as salt from the ocean. There's more salt in summer, less in winter. So it's like tree rings. You can see the dating all the way back, extract the air, and you can work out the temperature and the carbon dioxide. And the graph at the top shows the temperature. The present is on the right, 800,000 years ago is on the left. And high temperatures are at the top, low temperatures at the bottom. These temperatures at the bottom are ice ages. We have an ice age every 100,000 years when there's huge amounts of ice across the Earth. In between, having these interglacials, periods between ice ages, and that's where we are now. We're in an interglacial. There will be another ice age at some point. We don't know when. And this shows the amazingly similar relationship between temperature and carbon dioxide. People often say, well, carbon dioxide can't affect the climate system. Well, this is pretty good proof that it can. You can see how they correspond very closely. When we have a lot of CO2 in the atmosphere, we have high temperatures, and vice versa through the ice ages. So we have this big project at the moment, trying to get ice core even deeper, perhaps get 1.3 million years old. That would be fantastic, because you can see each ice age here is different. Each interglacial is different. Climate system is never simple, but using data from Antarctica, we can unravel it, even though it takes a lot of effort working down in that part of the world. And this was my last trip to Antarctica. I was drilling ice core, but a much shorter one, just about 15 meters in depth. These two ladies with me, professional field guide. We camped in the middle of nowhere on a place called Rothschild Island, here at the northern part of Alexander Island off the Antarctic Peninsula, hand drilling a core, not one of these really deep cores. Living in the field in 2 tents, fantastic. Hundreds and hundreds of miles from many human beings, keeping in touch obviously with our base constantly, but an amazing experience to visit. And it's a fantastic place. And I hope I've given you a flavor of what we do down there in terms of climate change. Thank you.
All right, John, thank you so much for sharing that with us. Just some, amazing imagery and the data that went along with it, especially that last graph showing that information, how the CO2 and the temperature just have mirrored each other for the last, 800,000 years, seeing those ice ages and then those spaces in between. So, I don't know how much more evidence we need. That's a pretty good record of evidence. All right, well, let's start there with the drilling, because we had a speaker joining us yesterday. Her name's Allison, and she drills ice cores, out in the Canadian Arctic, up in the Rocky Mountains. They're shallower ice cores than some of the deeper ones in Antarctica, but drilling down 800,000, to 800,000 years, or even further to 1.3 million years. What kind of depth are we talking about?
Well, the highest part of Antarctica is just above 4 kilometers. The plateau of Antarctica ranges between 2 and 3 kilometers high. So Dome C there, French-Italian project, that's about 3 kilometers of ice you're talking about drilling. 2 meters at a time. You can't just drill all the way down and pull it up. So you put the drill down, get your 2 meters, haul it up, take the core, put the drill down again. So it's an incredibly laborious task, but very, very important.
So are we talking weeks, months? How long would a process like that take?
Well, the project at Dome C took 2 summers, because you can only really work in the summer. Temperature up in Dome C in summer is plus minus 30, something like that, minus 20, minus 30. Vostok got down to minus 89. South Pole's up to minus 50. Dome C, you can't really drill in the summer at minus 50, minus 60. It's just too difficult. So that's 2 summer seasons of several months each. That's what we need.
All right. Well, I'm going to bring in Madame Reader's class to join us. They're joining from Waterloo in Ontario, Canada. And let's see if they have a couple questions for us.
Hi, guys.
Hey, how are you?
Good. How are you?
Good.
Everybody say hi. Hi. We've got 2 questions. Wes, did you want to come ask your question? You can go right there.
How thick of ice is the thickest part of Antarctica?
So how thick is the thickest part of Antarctica?
The ice, it's about 4 kilometers. 4 kilometers in thickness. That's sitting on rocks, because under Antarctica there are mountain ranges, and all this ice sits on top of these mountains. And if you could remove the ice, you'd see these mountains. Some of them have names. Some of them stick up through the ice and are known as nunataks. And people get those named after them. But the ice varies. A lot of it is 3 to 4 kilometers thick, so it's an awful lot of ice. And that's built up year by year. So Antarctica really is a desert. Certain parts of the Antarctic Peninsula might get 1 or 2 meters of snowfall a year. But high up on the high plateau, somewhere like South Pole, Vostok Station, you're talking maybe 5 centimeters of snowfall a year. And so the ice at the bottom, this million-year-old ice, it's just built up over 1 million years. Snowfall virtually every day. In Antarctica, you don't really get traditional storms in the center of the continent. You get something called diamond dust, which I think you get in Canada as well, which is a gradual fallout of ice crystals all the time. And so if you're there at night and shine a torch up into the air, you can see these crystals just falling out of the sky. And it's hard to believe that that's been going on for 1 million years. And we can drill down into that snow and ice at the bottom.
All right. I see someone there waving. Go ahead.
There's a follow-up to the question that you just answered, and that's from Caden right here.
So if there was no ice, would the water level reach the mountains, or would it be like would it just be underwater mountains?
Well, as I indicated, if all the ice in Antarctica melted, sea level would go up by 60 meters. And so you'd still have some mountains in Antarctica. You still have an Antarctic continent there. West Antarctica would disappear because the ice there is sitting on the ocean floor. So that would all disappear. But yes, there would be some mountains still. Antarctica wouldn't be a submerged continent.
Awesome. And then we've got a question here from Aurora.
Hi.
Hi, Aurora.
Do you know how many animals are left on the Antarctic?
That's a good question. I felt I should have shown a penguin today. People usually demand a penguin picture because there's not actually, it's so cold, there's not actually that many animals on the Antarctic continent. Penguins obviously very common. Some of them go quite a way inland. But emperor penguins are the largest of all the species of penguins. I think it's something like 18 or 19 different species of penguins in the world. Emperor penguins are the tallest. They breed on the edge of the Antarctic. And yet the first time I went to Antarctica was in 1989. And I was lucky enough to visit a huge emperor penguin colony. And there was thousands of them breeding there. They were just losing their fur because it was warming up. So a lot of penguins, we get different types, chin-strap penguins, Adelie penguins, and so on. You get lots of seals. You get different types of killer seals around the place. Fur seals, for example. There are not many birds there. Besides the penguins, you get various types of skua. But most of the wildlife in Antarctica is below the surface. It'd be very good to have a talk about the diversity. I think some people from my institute talked about the diversity of life in the ocean. We have a big diving program out of Rothera. Even in winter, people cut a hole in the ice and they go down, taking a lot of care, obviously. And under the water, it's amazing. There's just so much in the way of wildlife. So it's a little bit barren when on the surface, and because only 1% of the Antarctic is ice-free, even in summer. And there's no trees, there's no bushes. I think there's only 2 types of flowering plant there. There's a lot of lichen around on these little bits of rock. But around our bases, we have these protected areas, special sites of scientific interest, because the pace of life is so very slow in that cold climate, and there's a lot of restrictions about where you can walk, because they always say if you stand on some of this lichen, this green lichen on the rocks, your footprint can be there 10 years later, because everything evolves so very, very slowly. So it's very basic forms of life, and you have to be very careful. And there's a huge effort about what you can do, what you can't do in the Antarctic, because that's controlled by the Antarctic Treaty. It's a very, very special place. And there's a huge amount of regulations what you can do. You can't just go there and do any old project you want to. And so a lot of effort goes into conserving the environment there.
All right. Great questions from our group in Waterloo. Thank you. Yeah, I think Antarctica really is a surprising place of extremes. I think a lot of students might have trouble picturing it as a desert, right, with so much snow and ice. But the amount of precipitation isn't as much compared to other places around. And then the abundance of life in the waters. Wow, from the whales to the leopard seals, just sounds like it'd be an amazing ecosystem and place to visit as a diver.
Mm.
So we've got a question here online, and this is about clothing. What kind of gear are you wearing to stay protected when you're, like the last time you were there, you were in a tent, obviously pretty exposed, drilling some cores. What kind of gear are you using to keep yourself safe and warm?
That's another good question. Yes, the clothing has evolved hugely over the years. In the days of Scott, if you see pictures of Scott and Amundsen when they went there in the early part of the 20th century, they were wearing natural fur, things like that, and fur boots. It's all moved on a lot since then. And the principle, the people in the Antarctic tend to use the layer principle, because if you're working in summer, it can really get quite warm. If you've got a blue sky, it can be quite hot, and you can really get quite hot doing drilling, physical work. Not when the wind gets up. It can be very windy, and that can rip through you. So you have lots of different layers, from very thin vests to shirts to jumpers to thermal layers to windproof layers. In fact, when I went last time, I was given 6 pairs of gloves for doing different jobs. You have very, very fine silk gloves, because if you're touching instruments and it's cold, your skin can just stick. I mean, people in Canada will know this, of course. Your skin can just stick to a surface, metal surface. But then you have ever more thick gloves for different types of jobs that you're doing. And of course, you have to have very good boots. We buy a lot of Canadian gear, actually. I remember having mukluk boots with really thick, several centimeters thick soles. You can stand on the ice all day without your feet freezing. So Canadians are a good source of information for working in a cold environment. As I mentioned before, we have polar guides who work with scientists. You never go anywhere on your own in Antarctica. That would be really bad news. And so you tend to be pairing up a professional polar guide and a scientist. And these polar guides, they're there in the winter, because the people who go to Antarctica tend to split into 2 groups. There's summer visitors like myself who do a particular job and come back. And then there's people then in the winter to keep the bases running, plumbers, joiners, engineers to keep the generators running. They're important people, and scientists and doctors. But the polar guides in winter, they just love doing extreme things. And they will go camping and sledging in -50. I think it's like a badge of honor for them. They just love to do these things. But of course, it has to be all very carefully assessed. I mean, health and safety is absolutely paramount in the Antarctic, because people say, isn't it dangerous working in the Antarctic? Well, not really, because everything is assessed. You have to do risk assessments for everything, and you have to have the right equipment. And having the right equipment is absolutely essential. And we have lots of people with lots of experience who kit you out in all of the gear before you go south.
All right. Another question here from online about, at the beginning you showed the plane, the otter, and how it can switch to kind of wheels, or the skis. It looked pretty straightforward landing. You could see the runway in the one picture. Have you ever done any landings right on the ice? And what's that like?
Well, yes, absolutely. We transfer at our base at Rothera there onto these twin otter aircrafts. And all our drilling work is done in locations where there's no runway. And so I've worked on quite remote islands. We went to a place called Atadi Island where no one had ever been before. So you just have no idea what the surface conditions are like. So you tend to land on the top of the island, and the pilots, we're very skillful pilots, often Canadians. Canadians understand working in snow and ice. And they put the skis down, and they come in initially and just sort of kiss the surface. They just touch the surface to feel if it's firm or not, then take off again. And they do this 2 or 3 times just to lay down some light tracks, just to make sure that the surface is solid. Because the great danger in Antarctica is crevasses. And so these are just great big holes in the snow, but they can get covered by snow bridges. And so it can look fantastic from above if you're in a plane. You think it's a perfectly solid surface, but there may be a crevasse there. So when you come down and just touch the surface, you have to be aware that something, it may just give way, and then you take off again. You just never properly land. So the pilots are really good at just feeling out. It's not too bad if you've been somewhere before, or you have someone on the ground to tell you what conditions are like. But yes, you have to be very, very careful about that. And sometimes I've been on field trips and the base suddenly gets clouded in. I mean, there's a lot of particular flying problems in Antarctica. One is horizon. You need to see a horizon to be able to land. And you get whiteout conditions, or you get no horizon visible. There's white snow below, white cloud above. You can't see horizon, so you can't see the surface. And I've known people walk over little cliffs of a meter or so. You have to be very careful. You can't see anything. So if you're trying to get home, back to the base, and the weather closes in, you may just put your plane down, put up the tent, and just stay a night or two. So the planes are fully equipped to be in the field for extended periods of a few days or so, if you can't get back to base. So it's all a question really just of being very, very careful at every stage and planning for all sorts of eventualities.
All right. Well, I'm going to work in 2 more questions, but before I do, Madame Readers class, feel free to give me a wave if there is another question, but I've got a couple more from YouTube that I can work in as well. The first one being, oh, they might be coming. Yep. Okay. Let's bring them in for another question.
This is Oliver.
Hello.
Oliver.
How cold is the water in Antarctica?
Yeah, another good question. Water really only freezes at -2, about -2. Depends how much salt is in the water. But if you're seeing liquid water, it's no colder than -2. So in the Antarctic, really the continent doubles in size between summer and winter. Because it's so cold, the ocean freezes all the way around the continent. It's a big ring of ice, doubling the size of the Antarctic. But the ice is only about 1 to 2 meters thick. So that's pretty cold, the top of that ice. But below that, there is liquid water. So it's never colder than -2. Is the answer to the question. So if you're going to do some diving in winter, and a lot of our divers love doing that, it's cold, but you have to have all the gear on, but it's not too dangerous. But it's quite difficult for the wildlife, because that's so cold. Only certain fish can survive in water that cold. And ice fish is one type of fish we have down there, which literally has antifreeze as blood. And so that its blood doesn't freeze. I mean, you or I wouldn't want to be in the water without fully protective suit on. You have to be really protected. Some people do. I hear there's apocryphal stories. People do go bathing sometimes in the summer in Antarctica in the ocean, but you have to be very, very careful with that, because it is between about 0 and -2. So it's very, very cold indeed.
All right. One more question about the ice cores. So yesterday when we talked to Allison, she talked about the logistics of transporting them. They use helicopter, and then they have to have a refrigerator truck waiting by to get them right in and then delivered. What are logistics like for moving the ice cores after they've been drilled in Antarctica?
Well, we're very, very careful with the ice cores because they're very valuable, incredibly valuable when you think of the cost of all the logistics. And so they're usually in 1 to 2 meter pieces, and they're bagged up. They're all labeled very, very carefully, so you know which is the topmost all the way back in a nice sequence. And then you put them into cases, and they are sent back in the planes in these twin otter aircraft. There are many trips backwards and forwards. We take them to the base where they put into the freezers, sometimes with a food store. We have lots of freezers on the base. And then they're transported back to the UK by ship in freezers. And we often have containers on the surface on the top of the ships. And they're checked very, very frequently. The last thing we want is for the ice cores to melt. That would be a disaster. And so they're brought all the way back to the UK, put into freezer storage. And then they're often divided up vertically because lots of different groups want a bit of the ice core. And so they're about 5-6 inches across, and they're turned into little strips which different laboratories get and processed. But the main thing is to be very, very careful with them because they're very, very precious.
All right, I'm going to come back here. Well, John, I mean, I can see why you love being there. I think there's obviously the amazing wildlife, the amazing scenery, probably some of the excitement of being somewhere so remote, and the science and the research you get to do. How many trips has it been now?
8 trips. I hope to do another one day. Now, of course, the big problem with COVID is a lot of our fieldwork this season has been interrupted. But we've sent the ship down. We have to make sure we didn't introduce coronavirus to Antarctica. That would be disastrous. So we've been very, very careful. Everyone's been isolated before they went down because we have to go down and resupply the bases, get the fuel and food in. They can survive if there's no resupply 1 year, but it's not ideal by any means.
Yeah.
So people have gone down.
Yeah. All right. I'm just going to quickly, we have Miss Ramos' class just joined us. They are joining us from Miami, but I think there might have been a time zone mix up, but I do want to bring them in just to see if they have any live questions for you. So, hey, Miss Ramos, how are we doing?
Hi, how are you?
Good, good. So I think we might have had a time zone mix up because we're just wrapping up the event. But I'm going to share the link to the recording with you. But if your class has any questions about Antarctica, well, we have John. Do you want to ask one or two?
Yes. Alice, quickly. Question?
Here comes no one.
Hello.
Hi.
Are the animals in Antarctica surviving or not?
Yeah, I mean, are the animals surviving in Antarctica? Well, they've adapted over the centuries and millennia to the conditions, the very cold conditions of Antarctica. And so we were talking earlier about penguins, lots of beautiful penguins in Antarctica who have thick layers of fat on their bodies so they can survive in temperatures down to -50. And we were also saying that there are a lot of fish and whales in the ocean, seals. Most of the wildlife in Antarctica is below the surface of the ocean. There's a relatively small number of birds, specialist birds, in the atmosphere. Snowbirds, things like that. We get a few species there, but not that many. It's very hard.
Just to kind of build on that question, you know, they're adapted to these conditions, but you know, especially places like the peninsula and, you know, around the edges where we are seeing that warming, how is that affecting the wildlife?
Well, certain, if you talk about seals, some seals like warmer conditions, some like colder conditions, like chinstrap penguins. They have a little sort of white band under their chin straps. They quite like a lot of sea ice. They like to breed on sea ice. And so we've had some warming there over the second half of the 20th century, and they moved south. And so they can adapt to a certain degree with change, but there are limits. And so some of them move. This is why a lot of the biologists are studying what might happen over the next few decades as temperatures rise. Can they adapt? Some animals can move, some can't. So it's we'll have to watch.
All right, and Ms. Ramos, let's grab one more question. I think someone else just came up.
Do you guys try to feed the animals there, or you guys can't feed the animals?
So she's wondering about interacting with the animals. Do you interact? You know, if you're at Rothra, do you interact much or keep distance? I imagine. What are the protocols?
People sometimes ask, who makes the laws of Antarctica? Well, there's an international treaty, the Antarctic Treaty, which controls what you can do and what you can't do in Antarctica very carefully because it's a very pristine environment. We take a great deal of care with it. And so, and of course, we get a lot of tourists there now. We get 50,000 tourists a year there. That was before pandemic, of course. And the Antarctic tour operators have a very strict protocol what you can do. You can't go up and start patting the seals or penguins, even though you might want to. And so you have to keep like 2 meters from the seals, and you don't feed them. Now that's they have enough food. There's a lot of fish in the ocean, and they do okay. And so, yes, it's a bit hard. Sometimes you see like maybe a baby penguin which has been abandoned. What do you do? It's a bit like David Attenborough. Do you go and help it or do you not? But the policy is to leave the environment as it is and not go and feed or disturb the animals there.
Thank you.
All right. Well, I'm glad that our group in Miami was able to join us. I shared the link in the chat if you want to check out a little bit of John's experiences in Antarctica, how things have changed a little bit. And then he talked a little bit about drilling ice core samples, which is really, really cool. So John, one more really quick question came in on YouTube from Miss Shanks. And they're wondering, are there any studies going on about water pollution in the Antarctic? Does pollution, does the currents bring pollution there? Are the large amount of vessels having an impact? Is there any kind of studies like that?
Pollution's a real interest in Antarctica because talking about ice cores, I said they're a bit like tree rings. You can see layers, but a lot of pollution gets to Antarctica. As we drill down, we see the dust from volcanic eruptions. So famous volcanic eruptions like Krakatoa and Pinatubo. As you drill down, you see this layer of dust. So the air flows all over the earth. So carbon dioxide is in many ways a pollutant nowadays. And that all gets to Antarctica. And a slide I often show, if I have more time, is the amount of lead in the ice cores. And there was virtually nothing until the 1950s when people got a lot of cars. And so then gradually the amount of lead goes up until the 1970s when we had lead-free petrol. Then it starts to go down again. And so you see all these fantastic background signals of the world. And of course, pollution does get there from South America through the air. And pollution in the water also gets there. Ocean currents bring all sorts. I mean, in fact, we find alarmingly some plastic on beaches in Antarctica. Because around our base at Rothera, there are some beautiful little beaches where you might want to go for a walk in the evening. And it's rather scary that you can find plastic bottles sometimes. Not many, of course. But the world is a very interconnected place. If you throw a bottle away into some river in the Far East, say, it may end up in Antarctica. So it's a global issue, pollution. We have to be careful right across the world.
All right. Well, I'm going to bring Reader's class and Ms. Ross's class back in again. And I think, is someone coming up? Oh, we're going to squeeze in one more from Madame Reader's class.
Hello.
Hi.
I was just thinking, I heard somewhere, I forget, but I think there's been 6 laws broken in Antarctica.
Laws?
Yes, he's
Yeah.
talking about laws there. Have any of them been broken?
They're not really laws as such. I think it's this Antarctic Treaty is a way of defining what you can do in the Antarctic. So there's no police force in Antarctica, for example. But all the big nations who work in Antarctica have agreed to abide by these laws, the rules of the Antarctic Treaty. And I think sometimes, for example, you have to bring all your waste out of Antarctica. You can't just throw things down a hole. And so all the plastics come out of Antarctica. Now, and like waste oil, for example, you might have a slight oil spill. A barrel might have a leak in it, and you get a little bit of oil spilling. That's not good. So we scoop up all the oil and the snow and bring it out of Antarctica and dispose of Antarctica. So if these little infringements do happen to the rules of the Antarctic, we try and clear them up as fast as we can.
All right. Well, I want to give a huge shout out. Thank you, Ms. Ramos' class. Thank you, Madame Reader's class, for joining us today. A shout out to the YouTube crew. Thanks for sending us in some great questions. And John, thank you so much for giving us some time today, sharing your experiences and your expertise in the Antarctic. And we're pulling for you to get there that 9th time and have another expedition under your belt.
And I hope you get there one day, Joe.
Oh, absolutely.
Put it on your list.
Oh, no question. No question. Well, thank you, everybody. Don't forget, we have a full day of events still coming up today. 2 more days of events around climate change leading up to Friday. I hope everybody has a great rest of the day. And thank you for joining us today. Thanks, everyone.
Thank you.
Bye.